Advanced counting techniques. This topic is a sequence of the previous ones we've seen on counting and also on mathematical induction and probability. With these advanced counting techniques, we are equipping ourselves with more powerful techniques to find out formulas for events that we can see in nature or in our daily lives. The first definition that we need is recurrence relation, and this is more of a reminder that of the things we've seen before. Remember that a recurrence relation or recurrence definition is a sequence of numbers that can be described by an expression that requires knowledge of one or more of the previous elements of the sequence. And we also saw that the solution to a recurrence relation is an expression that doesn't require any knowledge of previous elements of the sequence. So let's see one example of modeling using a recurrence relation. Here we have the example of rabbits in an island. So suppose that you are running a simulation, a computer simulation, where you put rabbits in an island. Now you have to assume that there is no predators in the island, so rabbits get to live happily. You have to assume that rabbits will not be killed, will never die, and they will be healthy for all of their life, which for the sake of our simulation, their lives are endless. They will never die. So you place a just born pair of rabbits in the island for opposite sexes. So the rabbits will not breed until they are 2 months old, and after that, every month they will produce another pair. So that pair that they produce will be one of each sex, and those two can reproduce again with the same rules. They don't reproduce for the first 2 months, but after the second month, they produce each pair produce one more pair every month for the rest of their lives. So how can we come up with a recurrence relation that describes the number of rabbits at any given month from the month where you place the first pair of rabbits in that island? So to solve this, we need to come up with a table like this, which we'll discuss in the synchronous session. Another example of a recurrence relation is the Tower of Hanoi. So for this example, you know, this is a kind of a game, the Towers of Hanoi. So you have 3 pegs, 1, 2, 3, and then you have a number of discs of different sizes and arranged from the largest on the bottom and the smallest on the top. The goal of the game is to move all the discs from one peg to the peg in the opposite extreme of your set of pegs. So you need to move all the discs from here to this peg. The rule is that you can only move one disc at a time, and you cannot place a disc that is larger on top of a smaller disc. The question is, how many moves do you need when you have only one disc? How many moves do you need to complete the game when you have 2 discs and 3 discs and so forth? During the synchronous session, we'll study this game and we'll use a recurrence relation to describe the number of moves that you need depending on the number of discs in your game.